Hey everyone, welcome back to our channel. Today we're talking about a crucial aspects of operating system, that is memory management. Have you ever wondered how our computer runs multiple applications at the same time, or how it ensures that each program gets the memory it needs? This is all about memory management. What is memory management? So memory management is the process of handling memory allocations in an operating system. It ensures efficient utilization of RAM, allowing our systems to run multiple programs without crashing. Think of it like a smart organizer that keeps tracks of what data goes where. Now we'll talk about why is it important. Without proper memory management, your computer would struggle with multitasking. The OS makes sure that every running program gets its fair share of memory and prevent conflicts. This helps us in smooth performance and avoid system crashes. So the OS uses various techniques like paging and segmentation to manage memory efficiently. There's a fun fact that the first electronic computer, ENIAC, had only 20 KB of memory. That's less than a simple text file today. Compare that to modern computers with 16 GB or more RAM. Now I'll talk about virtual memory. So what is virtual memory? Virtual memory is a technique that allows your computer to run programs larger than the available physical RAM. So it uses part of your hard disk or SSD or extra memory, so even if the RAM gets full, the system keeps running. So here is how virtual memory works. So the OS moves less used data from RAM to a specific file on your disk called a page file or swap space. When it is needed, it swaps the data block into RAM. This process allows multiple programs to run smoothly even if RAM is limited. But there's a catch that disk storage is way slower than the RAM, so excessive swapping can slow down performance. That's why having more RAM is always better. Virtual memory plays a crucial role in running large program because if even RAM is full, virtual memory lets program keep running. It helps in process isolation and security. It prevents program from interfering with each other's memory. The OS uses smart techniques like paging to manage virtual memory efficiently. There's a fun fact that Windows use a page file called swap space for virtual memory. You can even adjust its size manually. You need just to go to system settings, then advanced performance option, and then we can tweak there it. Now I'll talk about paging. Paging is a technique that divides memory into fixed size pages to manage and allocate memory efficiently. These pages are mapped to physical frames in RAM. Instead of loading an entire program into continuously memory blocks, the OS loads small fixed size pages, hence reducing fragmentation and making small memory allocation more flexible. You can think of it like a book. Each page in the book represents a fixed size page in memory. The OS assigns these pages to available slots or frames in them, just like how pages in a book are placed in an orderly manner. Here's how paging works step by step. The OS divides the program into equal sized pages. The RAM is divided into frames of the same size. A page table maps each logical page to a physical frame in RAM. When a program needs data, the OS looks up the page table and retrieves it. This ensures efficient memory use and avoids fragmentation. Paging has several advantages like it prevents external fragmentation, hence memory is allocated efficiently. Due to paging, there are faster memory access and better multitasking. This is why the modern operating system uses paging to manage memory efficiently. Now I'll talk about page tables. The page table is a key component of paging. It stores mapping between logical addresses, that is virtual memory, and physical frames, that is RAM allocation. Whenever process requires memory, the OS checks the page table to locate where the data is in the physical memory. To speed up this process, modern computers use translation look-aside buffer, that is TLB, which is a small but fast cache that stores recent page translations. Did you know that most operating systems use a 4 KB page size? This strikes a balance between efficiency and memory overhead. Some systems even support huge pages like 2 MB or more for faster performance. Now I'll talk about segmentation. So segmentation is a memory management technique that divides memory into variable size segments, each serving a logical purpose. Unlike paging where all pages are of same size, segments can be of different size based on program's structure. Each segment corresponds to a logical part of program like code segment, which stores program instruction, or data segment, which stores variables and content, or stack segment, which manage function calls and execution flows. This makes segments more intuitive for programmers. You can think of it like a book. Instead of dividing a book into equal sized pages like paging, segmentation organizes it into chapters, each with a different length based on content. This makes it easier to manage and access specific sections. Here's how segmentation works step by step. The OS divides a program into segments based on logical parts like code, data, or stack. Each segment is given a segment number and a base address whose starting location is in RAM. A segment table stores information about each segment size and memory location. When a program accesses memory, the OS checks the segment table to locate the correct segment. This allows flexible memory allocation based on the program needs. Segmentation has some great advantages like logical organization of code, data, and stock. There's a dynamic memory allocation as its segments grow or shrink as needed. And in segmentation, there is better security because of different segments can have different access permissions. However, there's one drawback, which is external fragmentation. Since segments are variable size, free memory gets scattered over time, making it harder to allocate large blocks. Early computers used segmentation before paging became dominant. Now I'll talk about different features of paging and segmentation. So paging had fixed size pages, while segmentation can have variable size segments. In paging, the address is done by using page number plus offset, while in segmentation it is used as segmentation number plus offset. Paging and internal fragmentation only. It means that since the page size is fixed, that is 4 KB, and you just need to store the file of size 2 KB, hence 2 KB data is lost, like 2 KB memory is lost. There. So there's an internal fragmentation, while in segmentation there are external fragmentation. At some page are 4 KB, other page are 2 KB. So maybe the 2 KB page is of no use. Paging is used in all older systems while some modern systems have hybrid OS which use both paging and segmentations, while segmentation is used in most modern OS. So that's all for today. Thank you for watching.